Hello everyone and welcome to another tutorial. In this video you will learn on how to make interactive line cuts of a 2D color plot in Python. In particular you will learn how to take horizontal line trace and vertical line trace using Python. As a researcher you often come across color maps depicting data with one axis representing a parameter, another axis representing a different parameter, and color indicating the data of interest. Occasionally, we need to analyze data variation along specific axes. This is where line cuts prove invaluable. And the exciting part, we will all be doing this in Python. We will be doing this in two different ways. The first way is to use the method of indexing and take a line trace either as a function of x-axis or the y-axis. Second, we will be using interactive line plots. First, we start by importing NumPy and Matplotlib libraries. Suppose we have our x, y and z data stored in CSV files. Next, we import the x, y and z data from separate CSV files using NumPy's gen from text function. Here is the x data, y data and z data separately stored in a CSV file. So let's import this x data, y data and z data and plot in Python. Similarly, let's import the y and z data. I will just copy this. So with the data imported, we proceed to create the color plot using Matplotlib pcolormesh function. So let's specify the color map as jet, add a color bar and label the axis for better understanding. So this is how the plot looks like. So this is our experimental data where the x-axis denotes some parameter, y-axis denotes some another parameter, and the color represents the data. Now we want to take a line cut of the plot for say a fixed value of y. First we set the desired y value for the line cut. In this example, let's choose a value y equals 4. So basically we want to take a line cut of this data for y equals 4. So which is something like that. So let's set y value equals 4. Next we calculate the index of the closest y value to our chosen y value using NumPy's argmin function. So let's calculate the index. Now let's print out the index of the selected y value. This helps us understand which y value was chosen for the line cut. So you can see for this particular case the index corresponding to y value equals 4 is 160. So with the index calculated, let us now plot the line cut through the 2D dataset. So this specifies the data to be plotted along the y-axis Here Z is the 2D dataset and in third bracket idx comma colon extracts the row corresponding to the specified y value index idx. The colon indicates that we are taking all elements along the second axis, effectively creating a line plot from the selected row data. Now finally we set the title of the plot to indicate the y value at which the line cut was performed. So let's plot it. You can see this is how the line cut looks for y equals 4. Similarly, we can see how the line cut looks for y equals 2. So you can see this is how the line cut looks for y equals 2. Now we may encounter scenarios where we need to perform a line cut along the y direction for a specific x value. Now we may encounter scenarios where we need to perform a line cut along y direction for a specific value of x. For instance, suppose we want to analyze a data set at x equals 5. In this case, we set x value equals 5. Similarly, we calculate the index to the closest x value to our chosen value using numpy's argmin function. Now let's print out the index of the selected x value. With the index calculated, let us plot the line cut through the 2D dataset. So basically this line effectively represents the variation of the data along the y-axis for a chosen value of x-axis, providing insights into the behavior of the dataset at that specific x-coordinate. Finally, as before, we set the title of the plot to indicate the x value at which the line cut was performed. So you can see this is how the line cut looks for a specific value of x equals 5. Now let us do an interactive plot using Jupyter Notebook with the help of IPY widgets and matplotlib libraries. So let us first import IPY widgets and ipython.display, where IPY widgets is imported as widgets to create interactive plot, and display from ipython.display is imported to display the widgets in Jupyter Notebook. Now let's create a function to update the plot based on the slider value. This function updates the plot based on the value of the slider, which is a y position. As before, let's find the index of the closest y value to the current slider value. Let's clear the previous plot. So let's create a figure with two subplots arranged in a single row. In the first subplot, let's plot the color map. Now let's add the horizontal line. Now let's add the second subplot or the line trace. So now let's create an interactive slider. So the slider has an initial value of the mean of y values and ranges from the minimum to the maximum y values with a step of 0.1. So when the slider value changes, it triggers the update plot. So let's run the program. Sorry for this. As you can see, this is how the interactive plot looks. So now you can change the slider and it will show you the line trace corresponding to this dashed line. I hope you found this tutorial useful. Thank you for watching.